In the previous videos, we showed how you can create data pipelines that ingest data in real time from Snowflake to Outerbounds. Data pipelines are useful, but Outerbounds goes way beyond that. Namely, you can use the compute features of Outerbounds to train models, process data at large scale, fine-tune LLMs, whatever you might want to do in a way more cost-effective manner than using other solutions. So for instance, here, we have a bunch of compute pools with different instance types, and we could add anything here, including GPUs from different providers. And the best part is that we are able to use any instance types without any extra margins. No need to pay a huge amount of extra just because you are running Python code in the cloud. Now let's create this forecast flow that basically produces forecasts anytime the data updates for every zip code. So we get zip code specific forecasts. We have a time window that we want to look back to. So here's the time window. And then we query data from Snowflake for the time window to get previous data points. So that's the piece of SQL. We simply look at the timestamp is greater than our time window timestamp here. Now, the key part about the forecast itself is that we use this time series forecasting package called skTime that uses stats models under the hood. And then we iterate over all the zip codes we find from the Snowflake database and then produce the forecast for each one of them. Let's see how it works. Let's deploy this flow. And as we are deploying, I want to highlight one important thing. We need to make sure that the skTime and stats models are available in all the remote containers that we use. And here we are using the fast bakery feature to actually create Docker images on the fly. We don't have to write Docker files by hand. In 11 seconds, we got the Docker images done. And now we have a fully functional forecasting module in this whole setup. So whenever the data updates, we run now both the weather viz as well as the forecast. So that's pretty cool. So let's run the sensor flow so we can actually see some results. So now it is running. And after a while, as that completes, it should then trigger the downstream forecast flow. Let's give it a few seconds. Okay, now it seems to be running. That's cool. And then we can eyeball how it is working. Now it is running this forecast step. And given that it takes a while to produce all the forecasts, we have this nice progress bar that updates every time we go through this for loop right here. So we can eyeball the progress here. And in a few seconds, it should be done. Now we have all the forecasts. We can eyeball just one forecast to make sure that the results are not total nonsense for that one zip code. So let's look at the end step here. And in this visualization, the blue line are the data points we got from Snowflake, and the yellow line is our prediction how the weather will be going for the next 48 hours. Now, this is of course a bit boring. It's only a single zip code. What's more interesting is that we can also create these interactive dashboards, let's say using a tool like Streamlit on Outerbounds. So let's start this app forecast viewer in a port on the workstation. And the key thing here, by the way, is that it is behind the same auth wall as everything else in the platform. So you need to be in your user list to be able to access the application, which is a big benefit compared to just trying to host it by yourself. Now we have the forecast viewer here. We can simply click that link and that opens the forecast viewer where we have the same visualization, but now we can eyeball any zip code. We can check other places. Would need to have some backtesting to see how these forecasts then match actual weather. We were able to create the full pipeline, goes in real time from Snowflake, running forecasts at scale, and then finally allows you to eyeball the results in an interactive dashboard.